Okay guys, this one's sketching some graphs with first derivative and second derivative and just some characteristics. So sketch the graph of the continuous function that satisfies the given condition. Alright, so here we have f of 0 equals 4, f of 2 equals 2, f of 5 equals 6. We have f of 0 equals the first derivative of 0, f prime of 0 equals f prime of 2, and those equal 0. Remember, f prime, or first derivative, tells me is it increasing or decreasing? Is the slope positive or negative? Okay, and then here f prime is greater than 0, so that means it's a positive slope. For this algebra 1 absolute value, we'll go ahead and solve that. And it's decreasing right here for when it's less than 1. Okay, so let's go ahead and get started with that. So there's my XY ordered pairs, and then these guys are just ordered pairs right there. These just give me ordered pairs. Here's f of 0 equals 4, gives me 0, 4, 2, 2, and 5, 6. So I've graphed those guys right here. All right, these guys, when the slope is 0, that tells me it's going to be a relative min or a max. It's going to give me some flat points right there, some extremas. Okay, let's go ahead and solve this guy right here and find out where it's increasing. Okay, so from algebra 1, x minus 1 is greater than 1, or x minus 1 is less than negative 1. So I get it's f prime is greater than 0 when x is greater than 2, which means it's increasing when x is greater than 2. So it's going up right here when it's greater than 2, and when it's less than 0. So I know it's going up right here. Let's find out. Let's do the same with this guy right here. Okay, when I solve that guy, I get it's decreasing between when it's less than 2 or greater than 0. So it's only decreasing right there. So pretty much I can see it's doing something like this, and it's going, oops, sorry, it's going up and then down and back up like this. But let's get the concavity. Concavity is second derivative. So let's insert some more facts right here. Okay, so the second derivative is less than 0, which means it's concave down when it's less than 1, or when this guy is less than 1. Okay, so we'll do algebra 1 skills and solve for that one right here. Now we don't need to do this one right here because this is just concave up. It's either concave down or concave up. We already know the increasing and decreasing, so I'm just going to solve this guy right here, and this is where it's concave down, and it's going to be concave up everywhere else. So let's go ahead and deal with this x minus 4 absolute value less than 1. So it's going to be concave down at x less than 1, or x greater or less than 5, or x greater than 3. Okay, concave up everywhere else. Okay, so concave down when x is less than 1. So think of it, it's going to be cupping down. It's going to be kind of curving down like this when x is less than 1. Now right there at 1, there's going to be a pi, and it's going to change concavity and start cupping back up. Okay, and so then it's going to go at x equals 3 right here, it's going to go back to concave down. Okay, so it's going to go from concave up, and then it's going to go concave down. It's still increasing though, still increasing right there. So you get a general graph that kind of looks like that. Okay, so there's a pi right there, there's a pi right there, and there's a pi right there. Concave down, and then right there it starts to go concave up, and then right there it starts going concave down again. Oh, and it goes concave up again after x equals 5. I didn't catch that right there. Yeah, because it's concave down when it's less than 5 and greater than 3, and it's concave up everywhere else. Okay, so there's my general graph right there. Those are fun. I like doing those. Doesn't that look like fun? All right, so that would be the homework assignment I would assign you guys. And there's all the answers to the evens right there. Whoops, my infinities got a little bit shoved a little bit. Let me put them back there, my sideways eights. Okay, guys, that's it. Good job.